So in our previous video, so nagamatag na ni 1 bit ALU pero nagamit lang tag assign construct. So karon atong gaponing gamon siya pero gamit tag always non-blocking assignment. So magyapon atong truth table. So if our selector is 0 0, then we'll perform addition. Then if it is 0 1, subtraction. Then if it is 1 0, bitwise and then if it is 1 1, then bitwise OR. So then here's my code. So pangalan sa to module is ALU. Then natay input nga x, y, then s nga nakaboss. Duha man ni sila, s1, s0. So natay index diri nga 1 is to 0. Then output R and output COB. So COB is for our carry or borrow. Then begin. So if it is so sa atong circuit, so if our selector 1 is equals to 1, then it will go here, the next multiplexer. Then if it is our selector 0 is 1, then R is less than or equals to X or Y, so bitwise OR. Then if it else R is less than or equals to X and Y, the bitwise AND. So if it is our selector 1 is equals to 0, then doon siya dire. Sundon rin ni dyan si half adder din si half subtractor. So kay parihara man sila nga naka XOR. So else na to is R is less than or equals to X or Y. Then for our carry and borrow, then ano siya, if selector 0 is equals to 1, then if perform niya tong nasa half adder nga dali. So if it is 1, then not X and Y, else X and Y. So here's my stimulus generator or truth table. Then for our test bench, so we have here our selector wire X, Y, R and COB. Then we'll try to run it. Since there's no error, so we'll proceed to our PVP. Then our dump file. So we can now open our GTK wave. So here's our digital signal output. So compare natin na sa atong truth table. So if our selector is equals to 0 0, so then it is addition. So if it is 0 0, so r carry is 0, then r sum is 0. Then if is 0 plus 1, r carry is 0, then r sum is 1. Then 1 plus 0 is equals to 1, r sum is 1, then r carry is 0. Then if it is 1 plus 1, so r carry is 1, then r sum is 0. Then if our selector is at 0 1, so subtraction, 0 minus 0 is equals to 0 borrowed, then difference 0. Then 0 minus 1, we carry, then a difference 1. Then 1 minus 0, then difference 1, borrow 0. 1 minus 1, 0 borrow, then difference 0. So here for bitwise AND, if our selector is 1 0, then if it is if our selector is 1 0 and 1 1, then we will neglect our value of COB. So wala man na say value kay ang atong R is mohold ra si jag 1 bit. So kay naman sa 1 0, so perform na to bitwise AND. 0 and 0 is equals to 0, then 0 and 1, 0, 1 and 0, 0, then 1 and 1, 1. Then if our selector is at 1 1, so we'll perform the bitwise OR. So 0 or 0 is equals to 0, then 0 1 is equals to 1, 1 0 is equals to 1, then 1 and 1 is equals to 1. So that's all for today.